Hi everyone, video number 13 of flipped geometry. We're going to look at the surface area of a rectangular prism in this video. So, in the last video we looked at taking a prism and exploding it down to its two-dimensional form. So essentially taking a rectangular prism and cutting all the sides off and laying it all out. So here it is here. What we're going to do is look at how we calculate the surface area of this. Now obviously I could just simply look at each one individually and then add up all of the rectangles together. However, we ended the last video by thinking about this formula that the surface area in total is going to be equal to two of those base areas. So if we have a base, for example, this rectangular prism has those two bases. There they are. Those two base areas plus the area of its lateral sides, so the area of those four sides. So here we go. In order to get a base area, this is a rectangle, so we know that we've simply got area is equal to base times height. Well, here's our base, and let's call this our little h height. Now if that's the case, then this is going to be our base, and this is going to be indicating our little h height. Of course, that's the other one, so we would have that situation. Okay? So these two representing those two sides there. That we could do. So if we get that, we've got a surface area, SA, is going to be equal to 2 times the base area. So in other words, 2 times base times height, just like that. Let's pause for a moment and think about the area of the lateral sides. We've got 4 here, and if you look carefully at these 4, you'll notice that all 4 of them have this same distance in common. So that distance there along all 4 is equal. So in other words, that is equal to that. And in fact, you'll notice that they all line up this way as well. So what we end up with here is, if we put them all together like this, one really big rectangle. So all 4 of these together represent that lateral area. Now, the distance here, which is the same as the distance here, which is the same, which is the same, and the same, that's that distance between our two bases. So that distance, in fact, is right, oops, I'll use my glue. That distance is right here between the two bases. It's also here, of course. We can see it there. We can't see it on the other side right now. The name we're going to use for that distance between the bases is big H. So it's different than our little h height. This is why it's so important that you have a lowercase little h when you're dealing with the area of the rectangle. Because big H is reserved for this distance between the bases. So here it is here, big H is here as well, it's here as well. So that distance between those bases is our big H. Okay, so we have one side of this lateral area's rectangle. Remember, we're going for one big rectangle here, and we're going to get all 4 lateral areas at one time. Well, how do we get this other side? Take a look at this. This distance here, between here and here, is exactly one side of our rectangle. Okay? That distance there. Now, when this is folded up properly, this side here is actually the same as that. So that matches up to there. So if you imagine that is this side here, we've got this side and we've got this side. Now at the same time when this folds up, this piece here will match up to that piece there. So essentially those two fold up, this folds up, it matches up. So what we end up with are those 3 sides there. This top piece along here, when it's up, matches up to the top piece that comes up and covers the top. So we actually have this distance here fitting with that in the end, once this has been recreated. So we have all four sides of our base. Well, we know that. That's the perimeter. So the perimeter of our base represents the entire length of this lateral side combination. So all four lateral sides together. We have this distance from here to here representing the perimeter of the base. So in our formula, I'm going to represent the area of the lateral sides now as big H multiplied by this distance. And this distance is the perimeter of the base. So I'm going to represent it this way. Little p for perimeter and multiplication by big H. So here we have it. Surface area is equal to 2 multiplied by our base area, which is b times h, plus the perimeter of that base multiplied by big H, which is the distance between the bases. That will give us the surface area of this rectangular prism.